Okay, this next example, right, another solving a system of linear equations by graphing. So we're given two lines, and this is, just call it line 1, and this is line 2. And notice that line 1 is ready to graph using the slope-intercept form, so we can go ahead and do that. And so our slope is 3, right, or 3 over 1. So I know I'm going to go up 3 and to the right 1. And my y-intercept, right, my b, is going to be 0, comma, -5. Okay, so let's go ahead and graph this line. So -5 and with a slope 3. So we have -5, well, let's go ahead and pretend again I'm using a nice straight edge. That's my y-axis, and I'll just make the x-axis up here. Okay, because my intercept was -5. Okay, so I'll zoom in here. So -5, so 1, 2, 3, 4, right? Here's -5. So there's my 0, comma, -5. And I'm going to go, I believe my slope was positive, right? It was 3. So I'm going to go up 3 to the right 1. And so 1, 2, 3, right? Up 3, or if I use this, right? 1, 2, 3 to the right 1. Right? There's my up 3 over 1. And then I get my new point here, and I can keep going, right? I can do 1, 2, 3 over 1. And if we connect these points, again, with a straight edge, I'm just going to go ahead and, whoops, and make sure to draw arrows because this line does go to infinity. Okay, so there's my, let's see, my line, it was line 2. All right, so it's my L2. Okay, so the first line is, well, actually that was line 1, not line 2. That's line 1. Okay, so line 2, well, doesn't look too bad. Let's see, let's do it in blue. So 21x minus 35 equals 7y. We can use the slope-intercept form again. Let's solve for y. Well, y is on the right-hand side here, which is fine. We can divide everything by 7, or multiply by 1/7. And what do we get? We get, that's a big 1, y equals, and let's see, we get this guy, that's just 3x, and 35 divided by 7, and it's going to be negative, it's going to be 5. So I get y, if we rewrite this, y equals 3x minus 5. What do you notice? What do you notice with this line and the one we just graphed? Well, that's the same line, right? It's the exact same line. It's just a little bit in disguise, right? I mean, we just divided by by 7. So one equation is derived from the other. So here, when we graph this line, we've technically graphed it already. If you want, you can say the first line, whoops, was red. Okay, red. And then if you graph the blue line, well, you're just really graphing over it. So where do the lines intersect? Well, here, here, okay, here's my black. Here, 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 here. I mean, they intersect infinitely many points. So here, there is a solution, right? The system is consistent, and from the handout that you printed out, and where I explained a couple of concepts, a system is consistent when it has at least one solution. Well, here, how many points, how many times do the lines intersect? Well, they intersect infinitely many times. So this system is consistent, and there are infinitely many solutions, okay, and since there is a solution, right, again, from that handout, if you're looking at that, you should be looking at it, what do we know about our lines? Are lines dependent or are they independent? Well, here the lines are dependent, right? One line depends on the other. Again, we can derive one from the other. So that's, again, the third case, and that's pretty much it. Make sure you label your points. Again, show your work. Understand when a system is consistent, when it's dependent. And here actually there's no check. Actually, I should say that. You only check a solution when it has one unique solution. That is, if you have one unique point of intersection. I mean, here there's infinitely many points, again, which you don't have to check because, you know, you can check, you know, this point, this point, this point, this point, this point. They all work because they're the same line. Okay, that's the last example, or I guess case 3.